Okay, so as you guys all know, the next topic is the properties of crystalline and amorphous solid. Okay, so if we talk about the properties, so here we are discussing about the crystalline, and in this part we will discuss about the amorphous properties. So let me give you the overview of the crystalline. That crystalline is basically their particle is in axis and their particle is not in axis, and they are three-dimensional solid, and this is like no dimensional, no geometry, but they are having regular shape with geometry with shape, as well as they are three-dimensional. They're properly arranged, their particles are properly arranged. If we talk about this one, so this is non-directional as well as no geometry. Okay, so if we talk about the first property, that is the crystalline is well shaped, or you can say that they are having more shaping character. If we talk about this one, so they are having no shape. Okay, so the next property is they are having fixed or sharp melting point. And if we talk about this one, so they are having wide range, which means they are having range like 30 to 70, 80 to 70, but they are having fixed sharp melting point. For example, a crystalline solid is having 100 801 melting point, or you can say that the temperature to melt the solid, so that is fixed, that it will not melt in like at the downward of the like temperature like 800. No, it will melt on 801, that is the melting point. If you talk about this one amorphous, that can be, there is the range, they are not fixed. Okay, so this is having fixed sharp melting point, just because, for example, these are the particles of the solid, and they are having force of attraction. They are having force of attraction. They are having equal force of attraction. That's why they are tightly pegged. Okay, so that's why they are having fixed temperature for melting point. For example, there is a melting point. I have given you the example already. And if you talk about this one, so their particle are like this, they are not tightly arranged, and their force of attraction is not equal, they are irregular. So they are having the wide range of melting point. Okay, understand? So the next property, that is this is anisotropic, and this is isotropic. What does it mean? If this is anisotropic, which means that n means not, iso means same, which means there is not same of physical property at different angle. What does it mean, different angle? What does it mean? This is, for example, the x-axis and the particle are here. Okay, for example, I'm giving the you can see that what conductivity, let me give you the overview of the conductivity, which means that the flow of electrons. Okay, if I'm giving current to this particle, okay, so from here without access, so the conductor will be different. If I am giving the electricity from this side, so that will be directly into the axis, and that will be directly moved from the particle. So here will be the more conductivity, and here will be less conductivity. Okay, so this is, for example, the vacuum place, and here you can see that the different conductivity is there, different conductivity, but at the different angles, so the physical properties are different. Okay, if we talk about isotropic, which means they are having same physical property, same conductivity. Okay, these molecules are like this, they are irregular. If I'm giving this, I'm from giving this side, from this side the conductivity, from this side this side, so that is what, that is same. But if you talk about this one, this is, if I am giving from the axis, that will be different. If I'm not giving from the axis, that will be different. So that will be entirely different. So that is having different at, they are having different physical property at the different angles. If you talk about this one, so they are having same physical property you guys can understand easily with the help of the example. Okay, the next, if we talk about the physical property, that is a refractive index. What does it mean? It means that refractive index means turning of light. Turning of light, what does it mean? It means that if we are having a light, if we have light here and it is moving here, if the light is coming from here, it is moving here. So this is what, if the light is coming here, it is moving here. So that is what, that is the turning of the light. Okay, turning of the light, like this, like this, like this, like this. Okay, so these are having, they are having different, it vary, that you can say that the light is varying from the points to points, so they are having different property, or it vary from particle to particle or place to place. If we talk about this one, so they are having no refractive index, which means they will be having a, you can say, turning of light, but there will be the same property. Okay, the light will be different but having the same property. Okay, the light will be different, like there, here, but having the same property, like this. Okay, so this is the having the same property. If we talk about the next, you can say that the, if we are having a next property, that is a cleavage plane. What does it mean? It means that cleavage plane, let me give you the overview of the cleavage plane. If we talk about the next property, that is cleavage plane, which means that the particle, the larger particle is converted into the smaller particle but with the fixed shape. Okay, for example, this is a layer of a crystalline solid, and here we are having physical property. Okay, and not physical, we are having chemical property. Okay, and there's a layer of the crystalline, there's a layer of crystalline, and if we are like hammering this crystalline, so that will be cut from the center. Okay, so this will convert into the like different parts, but you can see that the size are same. Like for example, like this, the size are same, the cleavage plane, but the size is same, like the size of this one is converted to the smaller one, but the shape is same. Okay, shape is same because this is crystalline, they're having the fixed arrangement. If we talk about here this, so they are having no cleavage plane, because as you guys all know, they are irregular in shape. So how they will be having a cleavage plane in their like, you can say, the geometry. So this was about the some properties of the, you can say that, about the properties of a crystalline and the amorphous solid. So in the next video we will discuss about the geometry of the crystalline solid, like isomorphism as well as the polymorphism. Okay.